In Objective 5, our brief rest from graphing is over because we're now going to solve a quadratic by graphing and by algebra. In the first problem, we've got f of x equals g of x. F of x is defined as x plus 1 squared minus 4. G of x is defined as 0. So over here on the algebraic side, this is where f of x would equal g of x. Now over on the graphing side, we haven't graphed a parabola in a few lessons. So let's go back. We know the vertex of the parabola is at -1, -4. There's the vertex of the parabola, right there. We also know it's an up parabola because the leading coefficient is positive. In fact, it's a +1. The a value is a +1. So to graph the next few lattice points, I can go over 1, up 1, over 1, up 1. Now, I can also, to get to the next set of lattice points, I don't know if your teacher has told you this, but there is a pattern to the next set of points. When the leading coefficient is 1, it would be over 1, up 3. Over 1, up 3. Now, the next set of lattice points would be over 1, up 5. The pattern follows the odd numbers, but we don't need to go any further than that. Let's use these lattice points to help us graph the parabola. It's doing something like this. So that's a decent representation of that function, and we will call it f of x because it is f of x. Now let's graph where g of x equals 0. That's a constant, and since it's at 0, it's simply the x-axis. So there's g of x. Now, simply by looking at it, we know where the answers seem to be. The answers appear to be at +1 and at -3. That's where f of x and g of x meet each other. So let's go over on the algebraic side and let's do the same thing. Let's solve it algebraically. First thing we're going to do is add 4 to each side. So x plus 1 squared equals +4. Next step we're going to do is take the square root of each side. So x plus 1 equals, now the square root of 4 is not simply 2, it's plus and minus 2. Now, I'm going to subtract 1 to get x by itself. X equals. Now, where does that -1 go? I'm going to put it right there for a minute. -1 plus and minus 2. Now, what that's going to do is that's going to allow me to take the high road and the low road. If I take the high road with the plus sign, -1 plus 2 is +1. But if I take the low road with the negative, -1 minus 2 is -3. And sure enough, we get the same answers either way, either by graphing or by using algebraic techniques. Now, they also do this on worksheet 5. What if it doesn't work out perfectly and nicely? So I've got the same thing, new functions. Here's the f of x function, -1/3 x minus 2 squared plus 1. Here's the g of x function, 0. So again, this is where f of x equals g of x. Well, let me show you what I'm talking about by solving algebraically first. I'm going to subtract 1 from each side. Negative 1/3 x minus 2 quantity squared equals negative 1. Now, the way to get rid of that negative 1/3 leading coefficient is multiply by the reciprocal, which would be negative 3. So both sides get multiplied by negative 3. And we're left with, those two cancel each other, and we're left with x minus 2 squared equals negative 1 times negative 3 is positive 3. Now the next step would be square root both sides to get rid of that square, and here's where we're getting into a little bit of trouble. On the left-hand side, x minus 2 equals, on the right-hand side, the square root of 3 is not a nice, clean, whole number, so we're going to call it plus and minus square root 3 for a couple of seconds. Last thing I need to do is add 2, and it goes right there. So x equals 2 plus and minus square root 3, and that would be a perfectly fine answer from an algebraic viewpoint. But from a graphing viewpoint, it doesn't work quite that nicely because we really don't know what the value of square root is. So we're about ready to find out. If I want to take this to the nearest tenth, all I have to do, get my calculator, and take 2 plus the square root of 3, and that's what I get as my answer. Now to round to the nearest tenth, that would just be 3.7. So x equals 3.7, approximately 3.7. Now I'm going to go the other way on my calculator. 2 minus the square root of 3 equals, to the nearest tenth, it would just be 0.3. So x is approximately 0.3. Now, how does that come into play when we actually try to graph? Let's go back to the graphing method. We know this is a parabola. In fact, this one's a down parabola with a vertex at positive 2, positive 1. Now, with a leading coefficient of negative 1/3, we know it goes down, but again, I don't know if your teacher has shown you this, but when the leading coefficient is a fraction with a 1 in the numerator, the way to get to the next lattice point depends on the denominator. Since it's a 3, it's simply a matter of going over 3, down 3. Over 3, down 3. Now, let's try to make the best parabola we can at this. I'm not that great at doing this, but it would be something like this. Now that's just f of x. Now g of x very nicely is still 0. G of x equals 0. So again, it's the x-axis. There's g of x equals 0, and here's where our intersections are. That's my best idea of sketching this. But you can see the intersecting points are not at nice lattice points. And that's why the problem says round to the nearest tenth, and to really know where those intercepts are, you solve algebraically. X is supposed to be 3.7, so it looked like 1, 2, 3, I went past 4. It looked like it should be more like over here. If I had to do it over again, I'd make it about right there, 3.7. And the other intercept is approximately at 0.3, so it looks like I hit that one decently. The backside of worksheet 5 continues a lot of the techniques that we saw in Objective 4 for solving quadratic equations. It doesn't include graphing on the backside. It does have one additional concept that you probably already know, but it wasn't practiced in Objective 4, and that was solving through the use of the quadratic formula. And that's the quadratic formula right there. So one of the ways you might see it is like this. What if you had a problem like this? First thing we're going to have to do is, we can't solve this by taking the square root because we don't have a square right there, and this x is kind of keeping us from doing that too. So we do need to expand, and we're going to get x squared plus 4x equals 9. Now we want this to be set equal to 0, so I'm going to subtract 9 from both sides. X squared plus 4x minus 9 equals 0. Now this is not factorable. There are no factors of negative 9 that have a sum of positive 4. So I have to use the quadratic formula. Now in this particular equation, the a value is 1. The b value is positive 4. And the c value is negative 9. I'm going to plug these values into this equation. X equals opposite b, so this would be negative 4, plus or minus the square root of b squared. Well, 4 squared is 16, minus. Now I like to put 4 times a times c in parentheses because they are all grouped together. You are multiplying 4 times a times c. 4 times the a value, 4 times 1 is still 4, times the c value of negative 9 is negative 36. All over 2 times the a value, which in this case would be 2 times 1, which is 2. So we've got negative 4 plus or minus the square root, the subtraction sign, and the negative turn into plus. So 16 plus 32, 16 plus 36 is 52. All over 2. Now over here on the side, let's break down 52. 52, since it's an even number, it can definitely be divided by 2. So 2 and 26. 26 is 2 and 13. And there's my rationalized square root 52, 2 root 13. So negative 4 plus or minus 2 root 13 over 2. Now we just need to simplify this. The entire fraction is over 2. So I'm going to give both parts of this with 2 as the denominator. Negative 4 over 2 plus or minus 2 root 13 over 2. Now I'm just going to reduce each part. Negative 4 over 2 is negative 2. plus or minus. Now over here, these 2's can cancel each other right there. And I'm left with square root 13. So x equals negative 2 plus and minus 2 square root 13. Now that might look like one answer, but it's actually two answers. It's negative 2 plus whatever square root 13 is, and it's negative 2 minus whatever square root 13 is. All right, let's wrap this up with just a little word of caution. The last two problems on worksheet 5. They look absolutely horrible, but they're really not. So here's a practice problem. Here's a problem that's very similar to those. Now the last thing you want to do not distribute the negative 3. Don't square the x plus 4. The last thing you want to do is expand this problem and make it bigger. The problem is written with a perfect square in it already, so this is going to be one we can solve by taking the square root. We're just going to do algebra steps to get this answer. The first step, subtract 12. And I've got negative 3 times x plus 4 squared equals negative 108. Divide both sides by negative 3. And now I've got x plus 4 squared equals positive 36. Now the next step, I'm going to take square roots on both sides. And that leaves x plus 4 equals, remember the square root of 36 when I'm solving isn't just 6, it's plus and minus 6. So if I'm at that point, x plus 4 equals plus and minus 6. The last step is subtract 4. And I get x equals negative 4 plus and minus 6. And here's where I can take the high road and the low road again. Negative 4 plus 6 is positive 2. And the low road, negative 4 minus 6 is negative 10.